Hi, welcome to this tutorial video on how to use MokuLab's waveform generator. Waveform generators are used to produce analog voltage signals with different shapes, frequencies, amplitudes, and modulation characteristics. The MokuLab's waveform generator is quite simple to use, but I'm going to show you how to get the most out of it. So when you first launch the instrument, you'll see that it is divided up into two sections. Up the top, we have the settings for output channel 1, and down the bottom, we have the settings for output channel 2. From here, you can configure pretty much every parameter that you need, depending on the waveform. So for the sawtooth wave down the bottom, we can tune its frequency, we can tune its symmetry, its amplitude, and things like phase. But if we also wanted to tune the period instead of the frequency, what we can do is actually tap this little unit switch down the bottom left. And that'll allow us to instead set the waveform's period, and then the units will then carry back to frequency if we then switch back. Sweet. So on the right, we have these little icons. These allow you to quickly activate and deactivate each channel. So up the top, if we wanted to activate the sine wave on channel 1, we just tap that icon and that will be generating an analog voltage at the output. We can deactivate it by tapping it. We can change the waveform by selecting from this little menu here. So if we wanted to generate a pulse wave, what that'll do is actually change the little illustration on the left and bring up a couple of new parameters for us to tune, which is edge time and the pulse width. We can also select from different modulation types. So the available modulations supported are amplitude modulation, frequency modulation, phase modulation, burst modulation, and frequency sweep. We can access all of these parameters from a settings menu on the right. This is where you can set the frequency, amplitude, offset, phase of your waveforms, but you can also quickly select between alternate units. So we might want to characterize the high level and low level voltages of the signal. We might want to specify the waveform period instead of frequency, and we might want to be able to quickly adjust the phase using this little slider here. One of the cool things that we can do here is quickly synchronize the phase of the two waveforms at the outputs. This is useful if you want to make sure that both waveforms start at exactly the same time as they appear on the left. So if we, for example, set the phase of the sawtooth wave to be 0 to be in line with the sine wave, and then we want to set the frequencies to be equal, what sync phase will do is actually ensure that they both start off at 0. And they'll both finish one cycle at the same time in phase. The other thing that you can do here is copy settings from one channel to the other. You can do this by hitting the up or down arrows to either side of the copy settings text. So one of the really cool things about the MokuLab's waveform generator is the modulation modes. So if I want to apply an amplitude modulation to the output on channel 1, I just select the amplitude modulation mode there, and then I can configure the modulation frequency. I can specify the amplitude of that modulation. So this is the modulation depth. But I can also specify the source. So at the moment, it's configured to be modulating using an internal source. This is just a sine wave. But if I want to be a little bit more exotic, I can actually modulate the amplitude using the signal coming in on input 1. And what this allows me to do is tune the amplitude modulation depth based on the voltage coming in, so the amplitude of the signal in input 1. But I can also modulate the amplitude using the output from channel 2. So you'll notice here that channel 2 is producing a sawtooth wave with a symmetry of 50%, and the amplitude of the sine wave on channel 1 is now also being amplitude modulated by that signal. What's really cool is that as I adjust the symmetry of the waveform on channel 2, it updates the waveform, the modulated waveform on channel 1. And this is a really neat feature if you need to modulate the waveform with some exotic shape. Some other types of modulations that are supported include frequency modulation. So what this will do is modulate the frequency of the carrier between two values. In this case, if we set the source to internal, what this will do is modulate the carrier frequency by plus or minus 1 megahertz, defined by the FM deviation. And it'll do this at a frequency of 100 hertz. So the thing to note here is that the FM deviation is the deviation from the center frequency. So in this case, we would expect the output to be modulated between 9 megahertz and 11 megahertz. We also have phase modulation. This allows us to set the modulation depth in terms of phase. And then we also have burst modulation. So there are 3 different modes here. One is called gated, the second is called start, and the other is called end cycle. In end cycle burst mode, essentially what happens is a trigger event will occur and produce end cycles of the waveform before settling and then waiting for another trigger event. So what we can do here is specify the burst period based on internal triggering mode. But another thing that we can do is specify a different type of trigger. So for example, we could use the external trigger. And so when that trigger event occurs, it will, in this case, produce 3 cycles of the waveform before settling and waiting for another trigger event. We can also use the analog input to trigger this. And this is really great because it allows us to set the trigger threshold with very, very fine precision. So in this particular case here, if an input signal comes in that exceeds 450 millivolts, it will produce 3 cycles of the sine wave at 10 megahertz, and then it will stop and then wait for the next trigger event. The next mode is start mode. This is pretty self-explanatory. Basically, the output signal will start and will not end once a trigger event occurs. Again, it's useful to use input 1 as the external trigger input for this because it allows you to set the trigger level quite accurately. The final burst mode is gated mode, and this allows you to generate the output voltage as long as the trigger condition is satisfied. So with a trigger level of 750 millivolts, if the signal coming in on input 1 exceeds that, it will produce this sine wave at 10 megahertz. But as soon as that trigger condition is not satisfied, it will stop generating that waveform. If we instead use internal triggering on this particular one, then what it will instead do is generate a periodic burst signal. So we can specify the burst period, which is the time between bursts, and the burst duration. So the way it's currently set up, every 1 second, we will have 100 milliseconds worth of output, followed by 900 milliseconds of nothing. The final modulation option is sweep mode, which when configured with internal triggering will continuously sweep the frequency of the output waveform from the start frequency to the stop frequency with a duration equal to the specified sweep time. With external triggering, the sweep will begin as soon as the trigger condition is satisfied, and at the end of the sweep, the frequency will return to the start frequency and will not sweep again until the next trigger event. The last thing to show you is the ability to save and recall settings for the waveform generator instrument. Let's say that you wanted to configure the instrument in a particular way and then play around with different settings, but then we have the ability to quickly return to a saved state. What you can do is access the main menu at the top left, select the save and recall settings menu, and save the current state. Now, if we were to turn modulation off, change our waveform, configure the instrument in a very different way, then if we wanted to quickly return to our saved state, we simply access the main menu again, select save recall settings, and then load saved state. Thank you very much for watching. I hope you found this video useful. Be sure to check out the other videos online. And until next time, I'll see you later.